Uh, this is Professor Mohite. I welcome you on the behalf of the Department of Mechanical Engineering, Bharati Vidyapeeth College of Engineering, to this 5-day online Atal Faculty Development Program on research opportunities in robotics and automation. Today we have Mr. Vinod Atpadkar, sir, from SVR Infotech Pune, and his team member, Mr. Piyush Taylor. I welcome uh, uh, you, sir. Dr. Mr. Vinod Atpadkar, sir, is the CEO of SVR Infotech and closely work with government associations like ISRO, DRDO, BARC, VSSC, and many OEMs in India. And today, his team member, Mr. Piyush Taylor, is going to present on Vision Robotics program and different application on the novel product developed at SVR Infotech. I welcome you, sir. Without taking much more time, I request Piyush sir to take the charge of the session. Yes, thank you, sir.
Thank you so much for such a warm welcome, sir. Uh, I'm Piyush, and I'll be just briefing you with the project which we have developed at SVR regarding our vision system. But before moving to that, I'll just introduce a profile of our company. Basically, we at SVR Infotech deals with robotics and automation system, as well as development, which is novel to the world and as an emerging sector to the upcoming future. So we are located in Pune, and our core values involve innovative indigenous technologies for well-being of human life. We also and missions are we focus for design development and inspire evolved technologies which are evolving and which contain hybrid combination of all the different branches. We might not be properly securing perfection in one, however, deals with all the hybrid products and make out a evolved product combining all of them. This is our organization brief. We have developed various engineering services. We are associated with Space we are associated with ISRO with our software developed uh, and it's been called as Space. We also have products which are for automation, robotics, as well as electronic system. And of course, we provide training for those who are just are going to start their journey in this field. So today I'll be discussing one of our projects which we have made at SVR, which is object localization for pick and place application using 6 UF robotic arm. Uh, if we consider billiards table as a environmental space, and if we are supposed to ask that how can we separate these colored object without human interference, and it should be work totally automatic, then we have developed a code using OpenCV, which is an open source library, and we have used a robotic arm, which is 6 UF robotic arm, and have an accuracy of around 10 micrometer. So by combining and interfacing both of these, we have developed a sorting process using a robotic arm. So for that purpose, our initial base logic deals with taking inputs from the camera. That camera inputs will be fed it to our program, which will convert RGB to HSV. The reason behind doing this conversion is because of the fact that our OpenCV library have much grip for the HSV conversion as compared to RGB. There are around 150 plus conversion available for the machine actuators to perform. We have dealt with HSV. Then we have applied some algorithms, some functions, some parameters to the HSV image which we have developed, and then we have segregated what is according to our requirement. Suppose if we want to sort out blue colored object in the environment, then we have given parameters for that. If we want to sort out a red color environment, we have given parameters for that. So that can be customized according to need. Uh, and after that, after the process has been sorted out a little, we have developed a boundaries which are called contours in the computer language. in order to locate the pixels at their edges, so that it can be marked differently and can be located, which can be visualized from the naked eyes too. After going through that, we have located the center for the image, for the object which need to be sorted out. The object could be symmetrical as well as unsymmetrical. So in order to deal with that, we have taken the concept of centroid in order to minimize the error and improve the accuracy. The pixel coordinates which we have obtained from our camera is then converted into real life coordinates by scaling factor and calibration for our camera with the plane on which robotic arm will be working on, and that output is being fed to the robotic arm so that it goes to the position and holds the object and place it to the required destination. So with the OpenCV, there are a variety of applications which are possible. We can deal with face detection. We can deal with color stimulation. We can deal with one of the evolving technology. Driverless car is one of the basic involvement needed for it is OpenCV. How camera can sort out things which are required to feed the data to the user to input, so that it can help itself, it can be more optimized for its function. It is an open source BSD license, so that it does not, it is free to use. Everyone can use them and make it more customized according to their requirement. So in for giving a glimpse of our project, we have started with dividing the whole image which will be taken from the camera into number of frames. As we all know that if image are consecutively shifted with high frequency, it gives output as a video. So we have taken single frame of a video, and then we have divided it into different number of pixels. So for that purpose, the camera pixels, the camera position does matter, because the human eye can differentiate. Human eye have a quite high megapixel in high megapixel inbuilt in it. We have, I think, around 576 megapixels in our human eye. But in cameras, we do generally make up with prototypes. So there are other factors which come to the parameters do define some inaccuracy and gives improper results, which can be camera pixels. If we use 5 megapixel or more, that would work just fine. If we have a light intensity, uh, it can be a hindrance in the fact that the light is reflected back from the color, which need to be uh, sorted out. So that can be an issue sometimes. We have a camera angle, which is also an important parameter to avoid the reading of shadows in the environment. So as we initially starting with RGB format, we have converted into HSV, where in RGB each block coordinate in the space define the color. In HSV we have same, but as in the cylindrical shape, where H defines the color, saturation value defined for intensity as well as brightness. For defining a color uh, in the cylindrical format. This is a visualized tabular representation for HSV and RGB a little bit. Uh, for RGB, we have numerical values. For HSV, we have H in degrees, as well as, while we have S and V in percentage. So in order to make HSV available for our OpenCV environment, what we have to do is that we have to divide the H value by 2 for conversion of HSV into our OpenCV environment, and rest S and V values remain same. So suppose if we were to sort out blue color from our environment, then if we read the values for HSV for blue color, we have 240 degree, 100% and 100%. So by dividing 240 by 2, we get 120. So in range, we will be putting around 120, a little bit tolerance for some to avoid some errors. We're going to look that in the code when we will be doing hands-on our on our project. So initially we will be sorting the HSV into binary. So as just to make a notation to differentiate a color in black and white format. As you can see, there are some noise. A hand which is holding the colored object is also being noticed by the camera, which can there are certain types of noises which do generate from the cameras because each pixel is quite minute, and reading that value holds a give a chance for error. However, we in by changing a little bit in codes in our code, however, doing some calculation, we can minimize, we can almost reduce them by defining a threshold that if the size is greater than certain area, then we have to select that size, otherwise avoid it. So binary mask is displayed here where white pixels have a value so that has RGB value of 255 is will be the required input, required output, and the other environment is will be in black pixels that have a RGB value of 0. So when image has been differentiated, we need to mark the boundaries for a required object. Suppose if we want to hold on, suppose if we want to recognize a hand in a environment which is full of number of objects and blocks. So we do with contours. Contours just are the continuous points on the hand on the edge of the on the boundary of an object which has been sorted out. The limitations of contours is determined by the camera which we are using, because camera is something which is a input to our code, to our program. So if the megapixels are quite small, then two separate objects, if placed quite close to each other, will be read as one by the camera, and in hence will develop a same one contour in this case. However, increasing the megapixels gives quite fine results. So this is just a digital representation of image. We have certain values where each value is for the H value, and 90, 67 are for different values are, if a colored image has been converted into the values, then these are determined, these are scaled like this in tabular pixel format. There are other application of OpenCV we can use for face recognition, number of people count, can be used for traffic. Even at the time of this, when we have a pandemic facing, counting number of people entering a mall or entering a social place, quite be an effective solution for quite be an effective approach if we apply such a programming method in that. We have some vision-based applications, which is for number plate recognition. Self-driving car, of course, is something which is evolving day by day. Another important application involves defect detection, which is to segregate defected uh, grains from the good ones, and that can be fully automated and can be worked 24 hours, 24 into 7, and give a quite high efficiency with minimum involvement of people. So starting with that, let's start something related to programming where we can put our hands on about how how we can grab the input from the camera and how can we process the image up to our requirement. So for that purpose, we'll be requiring a laptop, of course, Python 3 installed some of the libraries which are mentioned here. We will be using software PyCharm to start with, and we need a web camera or USB camera. Both will be work just fine, and we just need what we need to be sorted out by a different color ball or boxes setup. So I'll just go to my software and open. I will just open it up. So for those who if we are just start with initial coding purpose, we need PyCharm. Can give a boost start because of the fact that it uses less RAM. It is light. It gives a variety of features. It is so much user friendly. So if one is starting just with programming, I think this PyCharm is quite a good mm, a good start can be achieved by him or her. So I have some previous projects open here, so I'll just make a new project uh, just to uh, create another example here for the work. I'll just name it Nov. I guess that would be fine. The reason behind using PyCharm terminal to download the libraries is quite an effective way rather than downloading and installing them in our command prompt, because there are some files which are not granted permission from our which need admin permission, and for that purpose we do not have availability of uh, taking admin permission for installing that libraries. That can be simply be done and can be run in our terminal. So I'll just brief you about a little bit about a PyCharm. We have this project name is Nog. We do not have currently any file. For coding anything in our file, we need an interpreter that will be open from settings. Okay. So here I will go to project Nog and project interpreter, where I have selected a mm, Python 3.8 as a interpreter, and it will show a variety of libraries and packages which I have downloaded and which I have already installed for my various project application. In case if some of them here are not upgraded, they have a new version available. It directly shows from here. If you want to add something, if you want to add a package, you can simply search it. You can simply call it from here plus sign, and then you can simply search. For example, if we go for OpenCV, then we have a OpenCV wrapper, OpenCV for Python. You can search for any other packages which we will be using in our program, can be easily be installed from here. So I'll just uh, select this one, this interpreter for my project, and I'll just create uh, a new Python file, and let's name it number one as of now. So starting with that, first of all, we have to uh, call the libraries which we will be using, the packages which are involved for the calculation. So in my case, I'll be using CV2 as well as NumPy. The reason behind using these is OpenCV is for color sorting and for algorithms we will be putting. However, NumPy will be taking camera pixels into an array and will be easy to uh, uh, put the algorithms to a wide variety of numbers in small duration of time. So starting with that, I'll just put import a CV2 and I'll put import numpy as np. So after that, I'll just create a variable. Let's name it pic, or let's name it img for the universal kind. And I will put a image in that. So for that purpose, I have to call cv2.imread, which simply the function itself defined what it's used. It will read the image. So the image which we have do not have here in our environment. So initially I have to import it from here. So for the timing, let's start with two blue type of picture name with two blue, and I will just call it here and paste it and make it demo. And okay, so in our parameter, I'll just make it demo, and the file will be available in my suggestion. I'll select that, and I'll just want to see that if the image which I have uh, uploaded in my environment is this one which I need it is without errors. So I'll just make it visualize a little bit. I am CV2. I am sure, and I'll just the parameters it takes is the frame, the title of our frame. So I'll just name it image, and I'll just put the address which is img, that is my variable, and I want the image to be shown for about uh, 10 seconds. Let's make it 10 seconds. And if I run my program, okay. So this was initially my image, which I have taken into consideration. I will be applying some algorithms. Fortunately, it is of blue color, so we have to pay wave for blue color. But suppose if I want to visualize the image for indefinite number of times, for that purpose, I can just simply write here 0, and it will just show me the image for infinite number of times until and unless I press some button on my keyboard, just like this, so it will be gone. So after that, let's put some algorithms and features to it. So I'll just convert my image to a black and white format, and let's see if I give I see a desirable result. It will be CV2, CV convert color. That basically will convert your image to a black and white format, and the parameter it takes is the frame, of course, the img, and the second one will be the calling function. So in our case, I want to convert it into, initially it will be available in BGR. RGB is spelled in OpenSCP as BGR, and I want to convert it into BGR to gray. So that defines here, and let's see if we have successfully implemented this. Okay, so it has been converted into black and white. So now let's put some real things what we want to do. So again, I will take another variable and name it HSV, and I will repeat the same steps with just a conversion to HSV format instead of gray. So that will be CV2 dot color to HSV. For let's see what HSV really looks like, and it is something reddish and pinkish and yellow. So that's it, something different from what we have originally what we have in our image. So as of now, we won't be digging deep into that. We will just put some values for our sorting purpose. So if we go to our PPT back, and if we see that what are values for blue color here, we have 240, 100, and 100. So if we convert into HSV, then we have to divide 240 by 2. That gives us 120. We will be taking a range of values that will start from 110 and will go to 130. So I'll just set LB at lower range, and I will put np dot array. I'll be using numpy because the process will filter each pixels and will check for these values. If they lie between these parameters, then it will let it in, otherwise it will drop it out. So I'll just select the values as 1110 and 100 and 100 as of now. And if I go to upper blue, then I will go for array and 130, 255, 255. The range can be changed, of course, according to our color. For precise actual color combination, we can use some digital sensors which give exactly the value which has been taken from the camera. So if in case if there are some shadows, some reflections, some angle problem or some texture issue, then that can be sorted out. After that, we will mask the image. Mask basically will be converting, we will be sorting out what is our requirement. CV2 dot in range, and we will select the frame of SSP variable which we have declared above. We will take a lower blue and we will take upper blue for our sorting purpose. Next variable will be res for binary conversion, as we have seen in our PPT slides for black and white display. So we have CV2 bitwise, and we will take same frame, that is IMG, and we will put the output to the same frame, that is IMG again, and we will take IMG into mask. But that will be a little bit tricky. I'll just make it mask, and we will apply the filter to our mask image. Uh, okay, let's see what results do we get by doing this. I'll just display rest. Let's see if there's some errors or something. Okay, so we have this display here. Let's display all the three images so that we can conclude what we are doing till now. So I'll just make it 1, 2, 3, and that will be my initial image. That will be my masked image, and let's display the gray image too. Okay, so I have this in here, and let's name it different. Let's name it 1, 2, 3 instead. That will be suffice for our explanation. Okay, so let's run the program again. Okay, now we have fourth image as gray, that is black and white format. We have our normal image, this one, number one. We have number two for our masked image, which convert black and white. And we have third image as the segregation, what is our requirement. As you can see, there is a little thing which has not been depicted by our camera. So that is because of the fact that they are having certain different angle visualization according to a camera, which can be because of a reflection, which can be because of some shadow, or which can also be because of the angle. So there are certain parameters which can be adjusted by giving a by giving a wide range to our code that can be customized directly. So now we will put some contours as we have discussed, so that it gives uh, it gives us the boundary notation for our sorted object. So I'll just use see contours. I'll create a variable contours, and I'll just skip the hierarchy because that parameter is in use as of now. So I'll just CV2 and I'll go for find contours, which will find the contours in my marks image. Marks is the one the sorting image which we have done here, and after that I will put some other parameters which are basically for its uh, better depiction. I'll just go for 3 1 here, and I will just check for CV2 dot change approximate, and this will go none. In case you do not know how all these we how all this has to be put into chain, we have some notation here just above, so that what values it will take as input. And I'll just print the length of contours which I have here. So I'll just put length and contours. So let's see if it actually prints something. It actually have got all these. Okay, so I have the images as usual, as we have already seen before. And here I have a printed value of 22. So out of all these, it is taking 22 as a number of contours which it has made is 22. But we want that contours to be displayed here. So for that, let's make it a little bit. Let's just display all the contours. So I'll go for CV2 dot and draw contours. I'll feed the input from IMG because the contours which will be drawn should be drawn on the real image. And if I go for contours, the variables, and I'll just put some parameters for its better visualization. Suppose if you want the contours to be made of green color, then let's make it 255 and let's make it green display. And I'll go for one here. Let's see what are the results. Okay, so I have this my normal image as image number one. Okay, I can see that some certain boundaries are displayed here, which gives me also some irregularities about a little patches here, which are not required, but I just required that there are two contours and two boundaries. So let's make a little bit threshold uh, changes in our code where we just want a few display of our what objects we have. So I'll just make a loop. In the loop, I'll just take what has to be displayed here, what is needed to feed our uh, controller. So I'll just check for all the contours and I'll just name it for contour in contours, and we will define area uh, as cv2 dot area contour area, and that area should be calculated in the parameter of contour. The same will go repeated again and again. So if area, the we will check the condition for uh, making it limited to certain value. So I'll just put something here, else it will just draw contours. Okay, so this should work. That if the area is greater than certain value, then it should draw contours. Otherwise, it should not. Let's run a code and uh, let's see here. Okay, so still I don't see any changes in that. There might be some. Okay, I have to make it contour because we will be we will be checking for each one, not all of them. And also, for the time being, let's avoid the display of these images. I'll just run my code again. Okay, so from previous, I think we have some limited display here, and let's print that how much uh, times or how much contours we have made. So I'll just print contours which are here. So I'll think we'll get some values. Okay, so these are all the coordinates of contours. Let's print the length instead, as we have done previously. Okay, so we got 292 and 350. That is also quite a number. But what we actually want is the precise location, because we won't be doing anything on the edges. This might be good or wonderful for the naked eyes, but the robot will work fine if we have some center value embedded in it. For that purpose, we will be using some coordinates. So let's find coordinates for this one. For that case, we will be using moment function. So I'll just name it M, and I will the variable will be taken cv2 dot movement. That will be applied to all the contour which have angle greater than 100 for in our pixel coordinates. So I'll just make it available here, and I will write values as let's call them the coordinates at cx and cy, and I will just make it int, and I'll just start with something, some parentheses, and I'll just make it m for coordinates 00m, and I'll put that in quotes. Sorry about that. 00m 10 in that case, and that will be divided by okay, again in quotes, and I have m00. That will be for the parameter. The parentheses will be closed, and I have some variables. Same will be for y, but y will be a little bit different. So I'll just put 0 first instead of 1. For x we have 0 1, and for y we have 0 1. For x we have 1 0. Of course, that can be changed, and that can be used if we want our space to be in landscape mode rather than portrait mode. So there should be any. Let's check if there are some errors in our code. And then that. Okay, so it's a syntax error. Uh, then we will just make it a condition that if m of m00 is not equal to 0, then this should go well. Otherwise, otherwise it shouldn't go into this function. So I'll just make a little bit changes. Okay, so again we have quotation issues here. Let's make it double quote instead of single. Okay, so we have made one condition for this one, and let's make another condition for our working. If I go, if this is not equals to 0, then I should just write else and tx and c, let's make it cy is equals to 0 and 0. Okay, so this looks just fine. Okay, so when the coordinates are being taken, I want that to be displayed to me. So that I'll just put a circle. Circle is a dot. Even a dot is a circle with 0 radius, as we know. So I want that to be applied to IMG, my image variable, and I want that to be CX and CY, and I'll just fill it with some other parameters which are required. So I'll go for 1 and I'll go for the same color. Let's repeat green as color again, and it should be -1 for our parameter value. I'll just also put a text to be displayed for my convenience. I'll just name it IMG again, and I'll just display a tag here as center. Okay, and I will put the location as CX and CY what we have obtained. However, we need to modify that a little bit because it's showing some error. Let's see, can be done. I'll just put some other values. The parameters need to be feed with, and the color, of course, again, let's make it same as before, green. Okay. Okay, so let's see if there any error. I'll just make it continue. Okay, so this is working quite fine. And let's put our code here. It's displaying something for this one. Okay, again. Let's change the parentheses to the different. Okay, that won't work, I believe. Let's put on phone on my charging. Okay, let's give and start it with 1 again. I think I messed up a little bit here. I'll just write it again. Code int. We should start with code M, and we have feed input as M10. Then we have M here again. We have feed input as sorry. We have feed input as M00 again. We have CY, and we have int again, and we will be repeating the same values. That will be M. Again, in this case, it will be 01, and we will divide it with something like M, and again M00. Let's see. Okay, so it should be M again, and let's see again. Okay, it is coming out to be quite fine, I believe. Let's print our coordinates here. If we should, I'll just place it like print, and I'll go for CX. That is my X coordinate. I'll go for print. That is my CY. That is my Y coordinate. And let's see. Okay, so it gives some error with this one. It's not a tuple. Okay, so here should be a bracket, I believe, some smaller in the code. Okay, so I have now my center displayed and I have two coordinates, x and y, and again x and y. So that is that is like workable as of now. So I don't have to worry about if the robot is able to detect my balls or not. The coordinates will be sent to robot. After that, I'll just make it. I'll just won't let the coordinates displayed. I'll make use of Modbus for the coordinates to be sent there. Meanwhile, what I can do is that I don't want the print length of control to be displayed. But what I want to do is that I want to apply this not to this image, but to some other image. So I have some other image here. I'll just copy it. Okay. Then I'll just paste it here. Meanwhile, if you have some questions, then you can surely drop them in the chat or you can ask me directly. Then I'll just change my uh, image format location from here to here. I'll just repeat the same. Okay, so I have now the different image and I have some centers which has been depicted while other are missed. Well, that is because of the values which has to be entered here. If I change it to something else, let's see if it gives different results, or is it the code just for one or two? Okay, so it doesn't give any results. It doesn't depict anything. So that range is not for any color, which has been depicted by uh, a program. I'll just change a little more. Let's change it to this, and let's run the code again. Okay, so no results as of now also. So let's change the value to some other. So we have three values here, and that can have different values till uh, different combinations. And stochastically, we do not have anything in our image. I'll just change it to a little bit same. And let's make it 110 again, and let's make it 13, and I'll make it 80. Let's see if we have some more results. Okay, now it has depicted some more values which are greater than previous. The color range can be important. Setting the current range is important uh, for the output to be displayed. What makes me wonder is that I don't want to apply it to the image, and I don't want it to be taken again and again. So for that purpose, I'll take input from my camera instead. I'll just put comment to this line and I'll just take input from a camera and let's name it cam, and I want it cv2 dot video capture, and I'll put 0. Reason behind taking it 0 is because of the fact that we are taking web camera, and if we are taking USB camera, then we have to change the value to 1, 2, or 3 according to our ports on which we have made the contact with the USB camera. So I'll just run my code again and see if anything changes. Oh, it gives some results, some errors to me. So instead of cam, let's take it IMG instead. Okay, the errors is different, but there is still an error. So I'll just make it cam and I'll take another variable and store that into the value of our cam. So I'll take another variable as IMG, which is same as before, and I'll put the readings from the camera to the reading into my code. So let's see if this goes. Okay, so do goes, but the result is not that much. I don't think it just captured an image of mine, but it is not flowing in cycles. So let's make a loop of what it should do again and again uh, without any pause, without any stopping in between. So I'll just make this whole into my while loop, and I'll just go this. Okay, so this has to be added. Let's see what result do we get. Okay, so it has been again captured my image, but this is because of the fact that we have set the value weight key here as 0. So if I put it like if I put it 1, that will be defined by my FPS. That will define my FPS. So if I have something like this, and if I see, okay, I have this image. Let's see if it gives some results. Okay, I have some depictions here in real time, what my camera can read, and these central values can be printed as well as sent to the robotic controller. So this is all working in real time. To which color we want to sort out, we can simply make the changes in our code in here. The range is an important factor which has to be set, and the same can be repeated again and again. If you want to initially check for green color, we can put some values here, then we can repeat the code, and or else we can just change the value in loop for the color combination here, and things need to be displayed. But there is another noise. If I write something like let's see, if I give this 100, so let's suppose if I give 00, what result does it give me? That is so inaccurate and that is so unsubstantiated to mention, but let's see what result does it give. Okay, it gives a lot of colors. The values are giving something which is uh, captured by the camera, but I don't want that all of them to be displayed, and there might be some noise issues also. So for that, I will just increase the area size to some degrees, some square pixel more. Okay, so and this is little bit reduced, but not that much. So I'll just increase it more. That if it has any effect on my programming. Okay, so it has been uh, reduced, but the area is quite big in itself because I think it is detecting brown color. I have a background of brown totally. I'll just make it more, and I don't want anything to be depicted for the same code. Okay, so it is coming clean. I guess that is also a quite good parameter we have captured there and mentioned. So okay, this was about programming. We have got the coordinates. We have printed them for our naked eyes. If we want that coordinates to be sent to a robotic controller, then we can simply uh, put a Modbus control, and as we can simply print the values here, we can simply send them to our controller interface with PLC. So meanwhile, if you have any questions, you can surely ask them, and I'll just move to further slides where we can how we have integrated the robotic arm with our controller with our PC. So we have taken a 6D of robotic arm where it has access as well as a gripper attached. The gripper has been coordinated with uh, the Arduino as well. We have if we start from initially, we have workflow of camera giving feedback to our PC. That PC is giving the coordinates to a PLC, as PLC is coordinating with robot. Then we have a robot as well as we have a PLC coordinated with Arduino for gripper control. The power supply is different for Arduino. We have extra wires attached and linked to it. The gripper is our self-made at SPI Infotech for better gripping as well as a flexible gripping for different size. The size can of course matters. We have made code for color sorting. However, size sorting can also be made, but due to efficiency of this gripper, the side is not a complex factor which has to be put. Nominal size with little bit differences up to certain meters can be adjusted easily. So this was our initial project setup, what we have done, and we have taken the photos in real time through a camera that has been depicted in this picture. We have sorted it for red color, and this was initially for calibration. Calibration plays an important factor because the pixel coordinates are different from the coordinates which are in real world. So there is some scaling factors which need to be calculated, which need to be applied, and a proper precise calibration has to be achieved for the better results, and not for the improper functioning of the robot. So the challenges which we have encountered here is basically more the hardest challenge what I can depict from our R&D about all these months is that how to make the robot, the PC control with the robot. The PLC is an effective way, but there is also an extra module which we have added Arduino. So that was a little bit interesting to take a challenge that how to avoid Arduino and control the gripper from the PLC, but they due to the limitations of PLC that it cannot produce uh, pulses, PWM pulses. So and also the power factor which is involved in that, as PLC is for industrial grade and it does not produce that much effective powers. So in order to overcome that, we have used Arduino Uno for small size. We have made our own PCB, so that will just escape, and that will just uh, avoid using all the other components. And then after that, we have used TCP/IP Modbus communication for the communication between our PyCharm software and the PLC. Uh, there were holding register values which need to be updated. We worked on that, and this was all then taken in form and worked in flow for the result. And this was about it. If let's uh, just see if I'll just show you how the end part or how the result which we have obtained by doing all this in synchronization, interference, and timing. So this was the stage which we have set up for the proper maintenance as well as placing the robot. And with high accuracy, the robot can even adjust itself. High accuracy as well as the gripper adjustment can be a little bit uh, provide comfortable to the working of this processor, because of the fact that if some light issues might be encountered in the process which will give inaccurate center, the center can be placed at the edge of the edge of the block. So in order to avoid that, uh, in order to make it comply to the working, we have used the gripper with flexible control. So as you can see, this has been sorting into blue, green into green, and red into red. Important part was in the working is this that the gripper, the control, the OpenCV program as well as the robot controller is taking acknowledgement after every block which is it has deployed in the at the right place. So when all the blocks are finished, it will wait for some extra blocks which are added for their upcoming. But there comes an issue with that. Whenever you put a block into the environment, then it will be detected at the edge instead of getting to its position. Suppose if you twirl the block into the environment, uh, then it will take coordinates in the air rather than when it is been going to a particular position. So to avoid that, we have to cover the face of the camera when the blocks are deployed, and then after that we can run, or we can just simply remove our covering. So thank you. This was about the OpenCV program which we have uh, deployed here. If you have any questions, you can surely ask them.
Hello, sir.
Yes, sir.
Hello, is there any question from participant side? Okay, sir, go ahead. Go ahead, sir. Please
Sure, sure.
continue. Yeah. Yeah.
So here are some products which we have made. Uh, some of them, many of them are of SR Infotech itself, and many of them have been made in collaboration with other organizations. This is one of the finest product which we have uh, made at SVR, which have a 5 DF articulated robot and have a payload capacity of 1.2 kg. It has maximum reach of 702 mm and footprints of 240 mm. So in this robot, we have managed the control via Arduino Duo, and we have used motors for better accuracy. The robot can provide a variety of applications, can be used and can be programmed to different themes, can be pick and place, can be screwing in or unscrewing the nut, can be even do some uh, future activities, and can be customized as a whatever according to the needs of the person. The same can be also be controlled with the GUI. Okay, another is a small 4D articulated manipulator which we have made, and can be used for. This is basically themed for pick and place application here, and it has three different motors which are taking extra load, and in order to avoid jerks, as well as the in order to increase the payload, there are fewer changes that has to be made. So uh, the size as well as the design has been made according to that only. We have another 10 kg payload articulated robotic manipulator. The application involved can be different according to the needs as well as the requirement. Important accuracy is to be maintained if we are dealing with robotic arms. Still in India, we are facing this tragic issue that we are importing arms from outside. So we have started something which have high accuracy. This is a robotic antenna testing system where the robotic arm will always be in parallel to the movement which has been shown by the outside module. Uh, in our case, we have this module which is facing towards the face of the end effector, and this is being always in parallel. So if we are the application involves uh, the fact that if we are to be too accurate, and if you have to take out unscrew a nut which has a high roof, and which has to be so accurate that even a small mistake can cost you a lot of money, then for that purpose we have made this high accuracy robotic uh, antenna arm which moves in parallel and works accordingly. We have another finest product which is compliant universal robotic leech. It is it is used for a pipe inspection at various places with a speed of about 40 millimeter per second and weight about just 104 gram. It is enclosed with IP54. It can be 64, 67 as well as 68 water, which makes it waterproof as well as the speed is quite fine that even in muddy terrains it can work just fine and get the readings about any problems or any leakage that consumes about 10 watt of power. This is a robotic farm vehicle for paddy crop, which is developed for CDEC Kolkata. We have used we have operated it through wirelessly by the use of BLDC motors for its drive purpose and steering motors for and stepper motors. I'm sorry, and stepper motors for its steering purpose. The load capacity and the load capacity and other technicalities are calculated, and this has been controlled wirelessly using an access point at the end line at the outside the box. It was waterproof to avoid any damage to electronics equipment which are placed inside. For controllability, we have used Raspberry Pi as well as Arduino Mega initially for the steering control as well as the GUI control from the access point. But for the control of BLDC, we need to regulate the RPM in real time. For that purpose, we have used four Arduino, four different Arduino Uno, which tends to regulate the speed of BLDC in real time, and it is communicated with Arduino Mega using I2C communication, and the values for RPM and distance has been taken initially from the user via GUI and been given to Arduino Mega and then pass on to Arduino Uno for the required results. We have other Grabo 10 kg payload module robotic grippers also, which can be in curvilinear or in parallel shape. One of the pick and place application robot which we have made here has been equipped with that only. The one which we have discussed today about OpenCV has been equipped with one of the grippers which was made at SVR. We have some other full opening grippers also. We have some minute miniature grippers which are for accurate as well as proper reading, which we mostly tends to come across when we are dealing with sensors. So this has a payload from about 5 gram to 80 gram. It is for electric drive. We have motors regulated to position encoders for the proper positioning as well as getting into position with defined RPM. The initial pickup, boost, and the acceleration, deceleration are being calculated because the sensor involved are quite sensitive in themselves, as well as the object which has to be on which the force has to be applied are quite sensitive in themselves as well. So acceleration, deceleration is another factor which has been added to its calculation for proper result. We have some surveillance robot which has been made which take information, gather data, and produce it and give it to in real time. We have it can be in form of pictures, videos. We have sensor involvement that can read the reading of soil about their moisture content or anything which can be useful for the calculation of spying. We have another project as ECG dealing with biological medical field in association with BARC. In ECG, we have used 12 channels ECG in real time that is helpful for the door-to-door ECG reading graphical interface. In that, we have used MCP controller and that has been communicated with RX simple serial communication has been involved in that, and its voltage functioning is about 3.7 volt, which can be easily provided with any tablet or can be provided with a customized mobile phone if we want that if we want the ECG to be printed out in real time at a particular doorstep. So it can record ECG of multiple patients in single recharge. No special mobile application required for viewing the reports. It is just available in PDF format. We have another flexible link robot gripper which is customizable in design and have various end effector options, which can be easily be changed and can be modified according to requirement of one need. The important advantage of having this is it is have a long reach, so it can adjust itself and put out error detection in case of wrong inputs given to it. We have another IoT robot named Mobo for direct control from an app. Involves for controllability via an app on wireless communication involved in this. For that purpose, we have used Raspberry Pi. Raspberry Pi is booted with the connections for hotspot, which are always open or something which is open at the current moment. So we have applied that technology, which is quite novel in this. We have used motor drivers for conversion of the for conversion as well as controllability of the robot wheels as well as motors. Caster wheel has been attached in the front, a power bank for onboard power supply to Raspberry Pi. We have some initial sensors as well as the interference with controllers, mostly Arduino Uno. We also have working with PIC controllers. We also have worked with MCP uh, and other controllers for either interference with the sensors. The interference can be single interference as well as hybrid, because integrating all the sensors interference is quite challenging instead of just working on one. So here is the few demonstration and the have kits. This is one of the finest project which we have here at SVR, ultrasound scanner kit for education. It basically scan out all the uh, environment around the robot, which can be used for mapping purpose. This can be used for obstacles. This can be used for path planning and other application. For ultrasonic sensor is being used in it. We have used the controller Arduino Uno and programming according a optimized program for its working. Even on a self-balance robot, which is a kit for education, and when once it started, it will move. It will just try to balance itself, and won't fall down, and have two motors working, as you can see in the depicted in the image. You can take the reference from the one which most of the malls available malls have for human walking. So this just balances the weight of itself. Any extra weight added can be adjusted and modified according to the code. The program is important. The optimized program which it has been born with is quite magnificent. We have a simple line following robot which depicts itself differentiate from black and white coloring, and moves to the allowed path. We have some bipedal robot which have a 4 and 8 DOF humanoid depiction and visualization. It can be they have been programmed for simple walking as well as dancing move. We have programmed for PT move. The program can be deferred and can be easily modified for education purpose. So here we have mechanical, electronics, computer, sales, as well as administration. We all work in consideration with the needs of each other to give mutual results from each of the field, and produce a hybrid product which is perfect in its own kind. And most of them are quite novel to these. Most of them are quite novel. And we have also have a training is at SVR. We have association partners with BSSC. We have association partner with ISRO as well as DRDO. We have Debonik Roy sir guiding us from BARC about our research publications. We have been due to lockdown, we have been working on various papers about our work which has already been completed before. This year we have published around 10 papers. We have other publication already been done. Our association partners are Tata Technologies as well as TDEC, ISRO, BARC, L&T as well. Some of the some of the depictions from our papers, which has been highly applauded here on design and vibration analysis. We have some design and dynamic simulation, some with control inherent vibration for flexible robotic system associated dynamics. As the Devornik professor has been guiding us for various mechanical implication as well as applications. We have developed control algorithm joint navigation of multi-degree of freedom flexible robotic system with vibration signature and some more. And here are some our area of interest and collaboration. We have uh, been working quite rapidly for service robot applications. We have some vision guided mobile robot. The same application can be how the same novel technology can be given to a humanoid robot for its working, for its uh, optimized as well as flexible procedure to work upon. We have teleoperative rotative wing flying robot as well as for drone specific applications. There are quite a number of labs which we have established. Uh, One of them, many of them has been greatly applauded with the novel introduction of the novel technologies and indigenous products. Some of them are here about RIT Islampur. We have established at Manav Rasna Delhi University. We have established at JLA University, Mathura. And we are being in guided with our mentors, Devin Roy sir, who is Division of Remote Handling Robotics at Bhabha Atomic Research Center and Homi Bhabha National Institute. He's a member of DST and he's a member of uh, he has been in this field for quite a while, has quite a experience and has been guiding us for various requirement uh, as well as things which need to be done for the in with the application with the implementation as well as application from the ideas which has been from made make in India. We have Kushwasa sir, just a former director. He is a former director, and under these leadership, we have been producing lot of products. And apart from this, we also deal with training for the one who are just evolving. So we have training which are quite effective training exercises to all participants involved. We have hands-on training, special kits for mechatronics. Hands-on training involves can be from related to hardware, it can be related to software. Software involves the programming as well as the logic development. Hardware involves logic development as well as components understanding. The all things are interrelated to each other, had to be worked in mutual understanding for proper results. We have mentorship for student projects on robotics as well as continuous guidance and mentorship will be provided by us to enhance the skill set and learn from experts. We have seminars, lectures for new technology developed in market for robotics. We also have a 6-month internship to students who want to explore and learn more in this field. Okay, so thank you everyone. This our contact details. If you have any questions for it, you can surely reach us at this email ID.
Hello.
Yes, sir.
Sir, I have one question.
Yes, sir.
Is there any opportunity for the student in your company to do the training and actually on the project in the field of robotics and automation? Is there any opportunity?
Yeah, we do deals with the internship projects. We do with capsule projects. So if you are coming up with some idea and that is quite novel and that has some innovation in that, then you can surely reach us. We will be working together. Else, if you want to just explore, you don't have anything in mind as of now, then you can surely ask us. Then we have some working projects every time here at SPR. So you will be included in that. You have to go through a process of interview as well as written test if needed, and then you will surely be welcome.
Okay, okay, sir. Is there any other question from the participant side? Is there any other question? Yeah, sir, can I propose the vote of thanks now? I think.
Sure, sure, sir.
Yeah, yeah, yeah.
I'll
Thank
just, Vinod sir, just
you.
Vinod sir.
Yeah, that's fine from my side because I was thinking if there are any questions, I can be a support you, but not a problem. Fine.
Okay, okay,
Yeah.
okay. Sir,
Yeah.
yes. Thank you. Thank you so much for your valuable time. It was wonderful session, sir. This is Professor Mohite from the Department of Mechanical Engineering. I would like to express my profound and heartfelt gratitude to our honorable guests, Mr. Vinod Atpadkar, sir, and his team member, Mr. Piyush, sir, for sparing us the time out of his hectic schedule. Uh, to address, guide, and inspire us today with his input and insights. Thank you so much for your valuable time, sir. And it was wonderful session. Yes, thank you. Thank you so much.
Yeah. Thank you.
Thank you,
Thank
sir.
you. And good, Piyush. And really thanks for your entire team for organizing this event.
Thank you. Thank you so much,
Thank you.
sir.